Hello and welcome back to our Math 7 class. I am Miss Monroe, your Math 7 teacher today. Today we're going to learn about classifying triangles. Our objective is by the end of class you will be able to classify triangles by their angles and sides. So classifying means like organizing or sorting. So we are going to be organizing triangles based on their properties. So if you haven't done so already on either MyMCPS or Google Classroom, you should have downloaded a capture sheet that looks like this. It is a PowerPoint where you are able to follow along in this lesson and fill out the notes by double clicking on inside of those red boxes and writing down your notes. Okay. Some of you were having trouble, for at least in my class, being able to view your notes because sometimes it's really small. In this case, it's large, but remember that you can use the zoom button to zoom in and better see what you're typing. But after you click in the zoom button, you might need to click this arrow button again in order to type. So if you haven't done so, pause the video, download this, and you can either print it, you can write it in your notes, or you can type in your notes. Yes, and anyways, back to the lesson. So classifying triangles. First of all, what is a triangle? A triangle is a shape with 3 sides and 3 angles. Hence the word triangle. Tri is 3, like tricycle. Triangle means 3 angles. And something special about triangles is that the sum of its angles is always 180 degrees. So this is a quick side note that we should all know that if we add up the 3 angles, these are the angles of a triangle. If we add them all up, they should equal to 180. So let's do 70 plus 30. Well, these 2 angles, that adds up to 100. And then plus 80. That's equal to 180. So that is a triangle. And all triangles will have angles that add up to 180. Same here, 25 plus 45 plus 110. We can look at this and we're like, this is definitely a triangle. And it is. And you can add up those angles and they will equal to 180. So 25 plus 45 is 70 plus 110, 180. So those are triangles. We can now classify triangles in 2 ways. We can classify it by its angles. So these, its interior angles. Or we can classify the triangles by the size of its sides. So the sides, like this. And those are the side lengths. Like if we were to measure it with a ruler, that's the side lengths, the size of the sides. Okay, so what are some ways to classify triangles by its angles? These are important vocabulary words that are in your capture sheet, and we'll list them all, but then we'll go over what each of them means. So we can classify triangles by its angles, and those are called acute triangles We have obtuse triangles, right triangles, and equal angular triangles. So there are 4 types of triangles if we're classifying them by their angles. So let's go in deeper. What are these words? Some of you might already be familiar with the word acute, obtuse, and right. We have already talked about these types of angles. So it's very similar when we're talking about triangles. Acute triangles means that the triangle is has angles that are all acute. And if you remember, acute means an angle that is less than 90 degrees. A 90-degree angle is an L. It's like a corner, right? A corner piece. If it's less than 90, then it's smaller than the 90 degrees. Okay, so it's narrower. There we go. So a triangle whose interior angles measure less than 90 degrees is an acute triangle. And in your notes, if you're following along, you can write here a triangle whose interior angles each measures less than 90 degrees. So let's look at some examples and non-examples. Let's look at this triangle. In this triangle, remember we're just looking at the angles. I see a 25-degree angle, a 45-degree angle, and a 110-degree angle. Well, 25 is less than 90, 45 is less than 90, but 110, that is not less than 90. That's greater than 90. That's not an acute angle. So this is not an acute triangle. Looking at this green triangle, I have 30, 80, and 70. Those are all less than 90. This is an acute triangle. And our last example, 40, 70, and 70, all 3 of those angles are measure less than 90. This is also an example of an acute triangle. Okay, so here in this worksheet, you are asked to list the triangle numbers that that fall under those vocabulary words. So acute triangle, we can see they already give us 1 and 5. So if we go back here, and I have a bigger picture, they already tell us that 1 and 5 are acute triangles. And that is correct because all of the angles, now here they don't give you the measurements, but we can see with our eyes that all of the angles in number 1 are less than that L shape. They are narrower than that, right? Same thing with number 5. And then let's see what other triangle has all of those angles that are less than 90. Okay, I can look at 7. 7 is definitely wider than 90 degrees. It's definitely wider. You should have chosen number 3. Okay, whoops. All right. So obtuse triangles. This is a triangle with exactly 1 interior angle that measures more than 90 degrees. So it has to be wider than that L shape, wider. So if you look at this, I have 1 angle that's 120. It's wider than that L shape. This is an obtuse triangle. This is an example. 120 is more than 90. We look at the yellow triangle. 25? Nope. 45? Nope. 110? Yes. This has exactly 1 angle that measures more than 90. Okay, this one just says more than 90. That's the more than sign. So it can have any angle that's more than 90. So yes, this is more than 90. we go, we'll put that in there. And then our last example, we have 30, 80, 70. None of these are more than 90. This is not an obtuse triangle. Okay. Let's move this. All right, so looking at our worksheet, our capture sheet. Which one of these are obtuse triangles? Now they give us 4 and 8. So let's look at 4 and 8. 4 and 8. 8 is kind of hard to see, but this is more than 90, and this one's also more than 90. It's wider than the L shape. Also, if it's 90 degrees, it either says 90 degrees or there's this little box right here. This means 90 degrees. So if it doesn't have that box or if it doesn't say, then we know it's not exactly 90 degrees. So 4 and 8, what other one is more than 90? You can pause the video and try it yourself, and then play the video again if you want to know the answer, to check your answer. So the answer, you should have circled number 7, or I guess written number 7 in the text box right here. Okay, that's an obtuse triangle. Right triangles. Right is in the word in right triangle. So right means 90 degrees. It has to have that perfect corner, that L shaped in your triangle. So a right triangle is a triangle with exactly one interior angle that measures exactly 90 degrees. So remember, if it has that box, we know that that is 90 degrees. And that actually tells you here too. So this is a right triangle. It's that perfect L-shaped corner. I can already see that has a 90-degree angle. This is also an example of a right triangle. And then this one, none of these have that little square and none of these equal 90. So this is not a right triangle. Looking at the capture sheet, I can easily see my right triangles. Can you? I think you can, because it has a little box. Those two triangles are right triangles, number 2 and number 6. They have that little box, meaning that angle is 90 degrees. And our last triangle type based on its angles is the equiangular triangle. Equiangular, I like to think of this as equal angles, equal for equal and angular for angles. It is a triangle whose interior angles measure exactly 60 degrees, or in other words, all of the angles in the triangle are equal. So if you look at this example, I have one 70-degree angle, another 70-degree angle, but our third angle is not 70 degrees. It actually cannot, because then it won't equal 180. So all 3 of these angles are not the same. This is not an equiangular triangle. But if you look at this one, all of the angles, all 3 are the same, and they equal 60 degrees. This is an equiangular triangle. An equiangular triangle, in order for all 3 of the angles to be the same, they have to measure 60 degrees. And that's because 60 plus 60 plus 60 equals 180. All triangles equal 180. So looking at our example, our capture sheet, there it is. Looking at our capture sheet, which triangle is an equiangular triangle? It is number 5, where you can see that all of these angles are the same. Number 5 is an equal angular triangle. So I told you that there are 2 ways that we are going to classify triangles. One by its angles, which we did, and now we're going to talk about classifying triangles by its sides. So there are 3 ways we can classify triangles by its sides: scalene, equilateral, and isosceles. And you'll see that at the bottom of your capture sheet right here. So, scalene triangle. A scalene triangle is a triangle with 0 equally sized sides. 0. None of the sides will be the same. They will all be different. So let's look. We're now looking at the sides of a triangle, not the angles. Okay. So looking at the sides, 3, 5, and 4. 3, 5, and 4, they're all different. This is an example of a scalene triangle. Uh-oh. We don't have any angle measures for this triangle. This is something new for some of you. But whenever you have these little tick marks, these tick marks show that something is congruent or the same. So because these tick marks are on the sides, it's saying that the length of this side, BC, and the length of this side, AB, are the same. They can be equal to any number that we don't know. They can be equal to 2 centimeters or 8 meters, who knows? But the tick marks mean that they are equal lengths. So those 2 sides are equal. But a scalene triangle, none of the sides have to be equal. So this is not a scalene triangle. It has 2 sides that are equal. This is not a scalene triangle. Okay, let's see if I can move this all. There we go. And we have a bunch of examples. 8, 4, and 12. Different, all different. So we'll put that there. Just move it to the side here. That's a scalene triangle. And then our last example, triangle EGO, 7, 13, and 14, they're all different sides. So this is an example of a scalene triangle. Ta-da! So looking at our capture sheet, which are scalene, they give us 2 and 3. 2, yep. I can see that one is really short, one is medium length, and one is long. 3 is long, medium, short. And then we have to come up with what other ones. So pause the video here. All right, so 4, I can easily see this is shorter, this is long, this is medium. And then I had a hard time figuring out, what other one? I had to bring out a ruler. Now, some of you might not have this if you're doing it digitally, but I used a ruler to measure the size of the sides, because I was like, well, 7 looks like it has different side lengths. So I brought out my ruler. Dun, 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 dun. Let me see if I can find it. Took this out and I actually measured them, and I saw that this and the one over here, these were actually equal. But number 6, none of those sides were equal. So number 6 is a scalene triangle. The sides were not all equal. So then we have equilateral triangles. Equilateral triangles, it has that equal, which means equal. And because we're talking about sides, we're talking about equal sides. So equilateral triangles is a triangle with 3 equally sized sides. So all of the sides have to be equal. Like this, 2, 2, 2. This is an equilateral triangle. Oh, here we have tick marks. I only see that AB is the same as BC because it has the tick marks, but this side does not have that same tick mark to say that that's equal to the other two. So this is not, this has 2 equal sides, not all 3. But this one has all 3 of those tick marks saying that all of these sides are equal to each other. So this is an equilateral triangle. And they give us this one. They say number 5 is an equilateral triangle. It's also equiangular. Equilateral triangle. And our last triangle type is an isosceles triangle. Isosceles triangle. It is a triangle with 2, at least 2 equally sized sides. So we need to have 2 equal sides. Okay, I have 8, 4, and 12. They're all different. That's not an isosceles triangle. The tick marks. We have tick marks again. This has 2 tick marks, meaning 2 of the sides. It tells us that 2 of the sides are equal. This side is equal to this side. Awesome. So this is isosceles. Okay, they don't give us tick marks, but they tell us the lengths. 10, 10, and 6. Well, 10 and 10, that's an isosceles triangle. And then 2 tick marks. AB and BC, those are equal lengths. This is an isosceles triangle. Sometimes words are difficult to say, and that's one of them, I feel like, for me. So, isosceles triangles. Well, in the example, they give us 1. So in your capture sheet, 1 is an isosceles triangle. What are some other isosceles triangles? Tells us that we need to find 2 more. Eight. 8 is an isosceles triangle. Let's write the tick marks so that we can know that for sure those are equal lengths. These are equal lengths. And then number 7. We saw earlier that number 7 was not a scaling triangle, meaning that some of the sides were equal, and it measured it out. These 2 are equal. And actually, if you want to go back for an equilateral triangle, we should put these tick marks because all 3 of those sides are equal. So there you have it. That is how we classify triangles. We can classify them by their angles, or we can classify our triangles by their side lengths. So if you haven't done so already, please download this capture sheet and fill in the blanks. Fill in the red boxes by double-clicking and typing in your answers. You can change your font so that you can see it better. That is all for today. Hopefully by now you are able to classify triangles. If not, that's okay. You can always go back, rewind this video, and listen to this lesson again. I hope to see you all again soon. And yeah, probably by the time you see another lesson, I will have a different hair color. Okay, goodbye, everyone.